So, chapter 7, we're going to start talking about correlation. And correlation is if there is a relationship between two variables. It doesn't have to be positive and it doesn't have to be negative. But so a correlation just means that as one value increases, something happens to the other value consistently. It doesn't have to be perfect, but most of the values should either go up or go down, depending on how we're looking at it. And here's some examples. They talk about amount you smoke and likelihood of lung cancer. The more you smoke, the more likely you are to get lung cancer. The height and weight, the taller you are, the more you weigh. Tend to be, just because there's more of you than there are with short people. There's not a lot of space to put extra weight in short people. They go wider, I suppose, but as you get taller, you tend to get heavier. Demand for something and the price of something. If the demand goes up, the price will go up. And practice and skill. The more you practice something, the better you become at it. So if you practice a lot of piano, you'll become better. The more you practice statistics, the better you become at it. So those are examples of correlation. And to see if there's examples of correlation, if there's correlation, we use what they call a scatter diagram or a scatter plot. And all it is we graph the values. We have an x value, which is the independent variable or explanatory variable, and the y value or dependent variable. And we find the two numbers, and we draw a dot, and we keep doing that for all of those. And here's an example. What they did is we have diamonds. This is in your book. They have 25 different diamonds, and they have the price and the weight in carats, the depth, the table, the color, and the clarity. And so we're going to graph some of these to see, well, does price depend on certain things? And so the first one they do is weight. And so first we have to figure out, well, what is the x variable going to be? And we decided that it's going to be weight. As we can see along the bottom here, okay, we have the weight of our diamonds based on, as you can see, the smallest value in weights is 1 carat, and the largest one is just over 2 carats. So when we made our graph, we didn't start at 1. Remember, we always start at 0 to, so there's no misrepresentation there. So, but we wanted to make sure that we had something bigger than 2, just because nothing went over it. And in price, the highest priced diamond was, just under $15,000. So we chose a value just above that, just to make sure that all the values fit in there. And that's what they're saying here. We assign one variable to the x-axis and label it. Well, okay, we said the weight is the dependent variable, and price should depend on that. Sorry, weight is the independent variable, and price is dependent upon how heavy the diamond is. And we've plotted each value. We found the dot, and we said, okay. And notice here they're saying, well, this is diamond number 10. The price was $3,670, and it weighed 1.1 carats. And we can see that pretty much as we go up in weight, the price goes up. So there is some correlation here, and it's positive, because as this gets bigger, this gets bigger. If it had been negative, it would have been going down, and I'm going to show you those in a second. But that's all we know about the correlation in this, is that it does look like it's going up. The next one they wanted us to try as an example with color and price. Well, if we graph color and price, and they've put a point for each one of the colors and the price, and if we go back to the table, we can see here's our colors going from, looks like, 2 up to 9, I guess. So color goes from 1, which is colorless, all the way up until we get more and more yellow. And so that's what they're showing here. We didn't have any 1s, but we had a 2, and going all the way up to 9. And we can look here, we can see, well, maybe the price as color goes up, price, kind of possibly goes down, maybe it goes up. But it's harder to see in this case, and they're going to talk about it here in the, so we can look at, well, yeah, as color, it goes down a little bit. We can see, yes, these are lower here than these values, which had a high color. But it's not as strong as weight. Weight is far more important in the price of a diamond than color, because the highest priced diamond had a color of 4, and the two clearest diamonds had prices of $6,000 and $10,000. But the one with the worst color, notice, did have the lowest value. So yes, there is a downward correlation, but it's not heavy. So the types of correlations we have are positive, where both variables increase or decrease together. Okay, as the x value goes up, the y value goes up. Negative correlation says that as one value goes up, the other value goes down. So they go in opposite directions. Okay? As x gets bigger, y gets smaller. No correlation means that the dots are everywhere and there's really no way to tell that anything has one has an effect on the other. And the last thing is that there's non-linear relationship, which means that we can look and see, well, yeah, there's some kind of relationship, but it's not a straight line. And that's something we can't do anything about. We don't have a way to we can't give it a correlation because it doesn't have an effect. And I'm going to show you pictures. These are positive. This one here has a very weak positive. Yes, we can see that as these values go up, they're increasing. But there's a lot of low values too. But there is a somewhat positive value. This is a little more positive. Notice as it's going up, they're getting tighter and tighter together. They are, yes, there are still lower values, but they tend to continue to go up. There's nothing hanging way down here, and there's nothing way up here. And this one here is perfect. This has a correlation of 1. Correlations can have numbers. Positive correlations are between 0 and 1. Negative correlations, which is the next one, is from 0 to negative 1. Okay, again, this has a slight negative relationship. These values here are higher than those, but it's kind of flat. This is a little more pronounced, and this is perfect. This has a -1 correlation. That there is nothing out of line. For a -1 or a +1, it's going to be a perfect line. Okay, and they're saying here that from D to F is the correlation's getting stronger. Same with A. The first one was A to C. The first correlation, these correlations are getting stronger. Okay, these values are getting higher here, and R is what we use to calculate for correlation. This is a graph of a plot that has 0 correlation. There's nothing that says that this is going up or down, because notice these points here are higher than those, and these points here are higher than these, and as we go up, there's no, as x increases, y could either increase or decrease. There's no said way to explain it. Okay, and that's really what correlation means. Is there some kind of explanation? This is a nonlinear. Notice it looks like a parabola. Okay, it has a correlation, positive one on this side, but it has a negative one on this side. So if we were to do this out, we would actually find there would be a 0 correlation. Well, there is correlation. It's just that it's not linear. Okay, it's a curve. Okay, so because this has a curve to it, we can't talk about it in a linear correlation, but if we were to do other types of correlations, we would be able to find it. So to measure the strength of correlation, we've come up with this thing called R. I don't know why it's R. I really can't tell you. And what this R is this gives us a value. Okay, because that way we can explain it in a number form and go, oh, well, this is a higher number, this is a lower number. So what is the strength of that correlation based on this R number? And R is going to be between -1 and +1. It's negative if the correlation is negative, if the correlation is going in opposite directions. It's positive if they're going in the same direction. If there's no correlation, the points are closer to 0. The R value is closest to 0. If it's exactly 0, there's definitely no correlation. But numbers that are closer to 0 have less correlation. And here they're saying positive correlation goes between 0 and 1. Both variables are increasing together. And a perfect positive correlation means it's a straight line, has an R value of 1. A negative correlation is between -1 and 0, and one increases while the other one decreases, and a perfect straight line in the negative would be a -1. R is close to -1 have a strong negative correlation. R is close to +1 have a strong correlation. R is close to 0 have a weak correlation. They could be positive or negative, but the closer the value is to 0, the weaker the correlation. And here's some formulas. They're all exactly the same, equivalent. They're just written out differently. This is how you would do it, calculate R by hand. And what it's telling you to do is take your x value and subtract off the mean, then divide by the standard deviation of x. Multiply that by the y value that you have, subtracting off the mean of y, and dividing by the standard deviation of y. You add all of those up, and then you divide by n minus 1. That will give you the R. And then they give you a couple other ways that it can be done. Your calculator will do it in a different way. I'm going to show you how to do this one here on Excel, and then I'm going to show you the quick formula in Excel to use, which is probably how you're going to do it all the time. You will almost never, ever do it in any of these forms unless somebody says, please use this and calculate it by hand. In most cases, you're going to use the correlation formula coefficient. So.